students, welcome back again to the mathematics class of class 8th. In the previous 3 classes, we learned the squares. We also learned the methods to find square roots by prime factorization method and by division method. We also learned about the Pythagorean triplet. Now students, today I am going to make you learn the 4th chapter from the book, that is cubes and cube roots. What is a cube, students? A cube is a 3-dimensional figure with all its sides, or you can say with all its dimension, that is length, breadth and height equal. So using this concept, I am going to start this chapter. Let's see how. It is a cube, students, with all its 3 dimensions, that is length, breadth and height equal. This is length, this is breadth, and you can say this is height. So length, breadth and heights are equal. You can say, suppose this is a side. So students, if you have to find the volume of this cube, what formula do we use? Simply, generally, side into side into side. So we use the concept of cube to find the volume. We also use the concept of cube root. Where, students? To find the side, or you can say dimension of the volume. If, students, a side has been given to you, you can find the volume by using the concept of cube. And if the volume has been given to you, then you can find the side of that cube by finding its cube root. This we can find by finding the cube of any number. So using these two concepts, I am going to start the chapter. Let's first study the properties of the cubes. So students, what is a cube of a number? A number having raised to the power 3. See how. You can write it like, suppose you have to find 3 cube. 3 to the power raised to the power 3. You have to multiply 3 times. Whatever be the resultant number, that will be 27 is, so 3 cube is 27. 27 is the cube of 3. Suppose you have to find the cube of 4. So you will multiply 4 3 times. 4 4 is 16, 16 4 is 64. 64 is the cube of 4. Now students, the properties. So the first property of cubes is that the cube of all odd numbers are odd. Let's see how. Suppose if we take any odd number, and if you find the cube of that number, we will multiply it 3 times. So 81 into 9, which is equals to 9. 9 into 20. 78. So we can see that the cube of any odd number is also odd. 729 is also odd. And the next property is that the cube of any even number, even natural numbers, is also even. Suppose I have taken 6. So 6 into 6 into 6 will be an even number. 36 into 6. 6 is a 36. 6 is a 18. 216, and 216 as an even number. Next property is, students, that the cube of the number of the form 3n is the multiple of 27. Simply 3n is what? A multiple of 3, and multiple of 3 will be the multiple of 27. Let's see for a few examples. Suppose if for 3n I have taken a number, suppose 3 into 7, that is 21, and the cube of 21 will be the multiple of 27. So 21 into 21 into 21. Let's find the cube of 21 here first. Which is 9261. So students, we can see that 9261 is the multiple of 27. If you want to check it, you can also check it. 9261 divided by 27. 27, 3 ja, 3 7 ja 21, 3 2 ja 6, 7, 8. You can write 6. How many times will it go? I think 5, 7, 35, 5, 2, 10. It will go 4 times. 4, 7, 28, 2. 4, 2, 8, 9, 10. 16 minus 8 is 8. You can write 1. 27, again 3, 81. So we can say that any number, if it is the multiple of 3 or it is in the form of 3n, which will be the multiple of 27. Now students, the next property of the cubes is that any natural number is of the form 3n plus 1, then the cube of that number will also be the form 3n plus 1. Let's see how. Our form is 3n plus 1. Suppose take any number 7 and the form of this number is 3 into 2 plus 1. You can write it like this. 3 2 is 6 plus 1 7. And if you want to find the cube of this, then you will multiply 7 thrice like this, students. 7 7 is 49 into 7. 7 9 is 63. 7 4 is 28 plus 6 is 4. 7 34. Okay. Now students, you can see that this is also of the form 3n plus 1. See how. You will divide 343 by 3. You will get 3 1 ja 3. Again, you will note down 3 1 ja 3. What is left here? 3 4 ja 12. So what is left here, students? This. You can write 3 into 114 plus 1. This is also of the form 3n plus 1. So this is the property that if any natural of the form 3n plus 1, then its cube will also of the form 3n plus 1. Students, the next property, that is, if any natural number is of the form 3n plus 2, then the cube of that natural number will also be the form of 3n plus 2. Let's see how. Take any, what is the form first, students? See, 3n plus 2. Take any natural number 11. Write this in this form, that is, you can write by dividing it by 3. 3 3 is 9. You can write 3 into 3 plus 2. I have written 11 in this form. Now what you have to find? You have to find the cube of 11. By multiplying 11 3 times, you can find its cube, and we all know that the cube of 11 is 1331. Now you have to write this of the form 3n plus 2. For that you have to divide it by 3 4 ja 12. Again 3 4 ja 12. 3 3 ja 9. What is left? You can write it, students, how. 3 into 443 plus 2. Again you can see this is of the form 3n plus 2. So students, let's see the next property, that is, the cube of any negative integer is always negative. See how. Minus 2 into minus 2 into minus 2. First we will decide the sign. Minus minus plus, and then again plus into minus is minus, and then we will multiply the numbers. See one more example if you want to see that minus suppose 4. Cube of minus 4. It is students minus 4 into minus 4 into minus 4. You can write minus minus plus and plus minus is minus. We always decide the sign of the product by multiplying the integers, by multiplying the sign. And now we will multiply the number for 4 the 16, 16 4 the 64. So the minus 64. Students, one more thing I would like to tell you, that if it is minus 4 to the power 3, here the sign will all be negative, but the power is not on the negative sign. Here the power is on negative sign and on the number, that is 4 also. So here the power is on minus 4, but here the power is only on 4. But the result will be the same because minus sign will be written as it is and you can write it as it is. But if it is suppose minus 4 to the power 2, then it will be minus 16. Next students, the seventh property of this is, for any rational number, suppose this, we can separately write the powers for the numerator and power for the denominator. You can simply solve this. If you want to solve this, 2 into 2 into 2 upon 3 into 3 into 3, you will get 8 upon 27. Next property is, students, cube of any number which ends in a 0 ends in 3 zeros. Let's see what is that property. Suppose 10 cube. How many zeros are there, students? 1 0. So the cube of this number will end with 3 zeros. If suppose there are 2 zeros, then students, how many zeros will be there? 1 2 1 2 1 2. Always there will be 3 zeros in the last. If there are 2 zeros, then there will be 6 zeros. If there were 3 zeros, then there will be 3 zeros in a pair of 3. Okay. Next property is, students, that the cube of the numbers ends with the digit 1, 4, 5, 6, 9 also ends with the same digits respectively. See how, students. Suppose any number is 11 and the cube of this will also be ends with the 1. The number 11 ends with 11 and the cube of this also ends with 11. Now, suppose any number is 14 and the cube of 14 will be, let's find, 4 4 is 16, 4 and 4, 5, 4 6 is 24, 2, 4 9 36, 37 38, 3, 4 and 4 is 7, 196, that is 4, 4, 17, 2, 7, 4, 4. You can see that if a number ends with 4, then the cube of that number will also ends with the digit 4. Similarly, the cube of the digit which of the number which ends with the digit 5 will also ends with the digit 5. Cube of the 16, if the number ends with the digit 6, the cube of it also ends with the digit 6, and the cube Suppose 29, if we are taking 29, the cube of 29 will also ends with the digit 9. So this is one of the very beautiful property of the cube. Next property is, students, that if any number which ends with the digit 2, then the cube of that number will ends with the digit 8, and vice versa, or you can say in the reverse way, if the any number which ends with the digit 8, then the cube of this number will ends with the digit 2. See how. Suppose if we are taking the number 12, then the cube of this will ends with the digit 8. If you want to check it, you can check it also. 12 12 144, again multiplied by 12. So we can easily see that any number which ends with the digit 2, then the cube of that number will ends with the digit 8. And in the reverse way, suppose this number is, take any number 18. The cube of the number which ends with the, suppose any number which ends with 8, then the cube of this number will ends with the 2. If you want to check it, you can check it also. See, the cube of 18. 8 into 64, 6, 8 into 8, 4. 8 4 is 32, 3, 8 2 is 16, 17, 18, 19, 8 3 is 24, 25, 3, 2, 4, 2, 3, 5, 6, 7, 8, 3, 4, 5, 5, 8, 3, 2. Any number which ends with the digit 8, then the cube of that number will ends with the digit 2. Similarly, students, there is one more property related to this, that is previous property, that if any number ends with the digit 3, then the cube of that number will ends with the digit 7, and if any number ends with the digit 7, then the cube of that number will ends with the digit 3. See how. Suppose 13, you want the cube of this number will ends with the digit 7. See how. 13 into 13 is 169, into 13 is 3 6 are 18, 19, 20, 3 1 is 3, 4, 5, 169, it will be 7, 9, 1, 2. You can see that this digit ends with 2197. If it is 3, then the cube of this will ends with the digit 7. Similarly, if you want to check it for this 17, then this digit will ends with 3. You can check this also, students. See how 17 into 17 is 289 multiplied by 17, 6. This will be 9 and this is 4, 4913. You can write 4913. So we can easily see that if any digit ends with the 3, then the cube of that number will ends with 7. And if any number will ends with 7, then the cube of that number will ends with 3.